all possible next states. Okay. So you already said from the initial state, what is the thing you are going to follow for the next step? It is that all possible from the initial state, all possible states that leads to the next state. That is the successor function. For example, see, successor function can have two fields. One is action, another one is successor. So from A, what are the action for A? Suppose if this is the state for which we are going to find the successor function means, for A, if you do what action, you will obtain the particular successor. So, for example, from A, from A, what are the successor steps? What are the next steps? You can lead to B, C, D. Okay. So you can also lead to B, you can also lead to C, you can also lead to D. They are all successor functions. B, C, D. And if you do what action, it leads to D. Suppose if you move horizontally, right side, that is known as action. Okay. If you do what steps, diagonally, if you move, you lead to C function. And vertically, if you move, you lead to D. That is known as successor function. So successor function has got actions and two fields, action and successor. So all possible states that leads from the particular state is known as a successor function. And goal test is obviously opposite to the of initial state, wherever the end state, that is your goal state. And path cast is, what is path cast?
Would be the cost of resource to reach the next state.
Yeah, cost between the from the current state to
or time.
Yeah. So correct. It is the cost between the two states, that is from current state to the next state or successor state. That is known as path cost. The overall cost will be the cost of all the states which you have traveled. But simply path cost means it is a cost between two states, current and next. Next, problem types and characteristics. All problems can be fallen into four types. These are those types. Different names also we have got for all those types. Observable can also be called as deterministics or single state. And similarly, multiple state problems can also be called as non-observable. And non-deterministic state can also be called as partial. And fourth one is unknown state space. So overall, we have got four problem types: observable, non-observable, partial observable, unknown state. Okay. Observable. Can you tell me what is observable? What can you say as an observable state? Observable type of problems. One example. Forget about the example which is given here.
Okay, ma'am. If I take a banana and use a knife to cut it into two pieces, it will get it two pieces at my first cut. That is very observable.
Okay.
Problem.
Okay. Yeah.
I mean, the outcome could be very clearly definable.
Not outcome.
Mm-hmm.
Your the way you are going to solve the problem, no, it should be the entire state space, entire problem space. It should be clearly visible.
Okay, ma'am.
Like a chess, like in a chess, what is the movement you are going to play? We will not be know. Okay, what are steps you are going to play? You do not know. But the where you are going to play, what are the possible moves you have got? All this are all observable because the entire board is visible to you in front of you.
Okay.
Whether you are playing or your opposition person is playing. So that is known as observable problem or deterministic problem. Because of
the
which
problem
only,
space is fully aware. Is that?
Yes, it is aware, fully aware. Even though instead of moving one bishop, is going to move, is a queen or king. A big, it is observable. If he moves queen, what will happen? He can able to determine. The other person can able to determine. If he moves a queen, what will happen? What is the consequence? If he moves a bishop, what is the consequence? He can able to observe everything, clearly visible. Everything is visible if in front of him. That is known as observable. Yes. Yeah. Next is non-observable. Can you say some example for non-observable? Obviously, you cannot able to observe everything. You cannot able to observe what is available in front of you. As it goes, you can once the particular state arrived, you will know that okay, this is a state. Not in beforehand. That is non-observable. One example.
Okay, the traffic, when I move into the traffic, I do not know what,
perfect.
how much level of
Yes.
traffic is there.
Exactly. So similarly, the example which is given in the slide also can be the non-observable example. Robot vacuum cleaner, no? Vacuum cleaner without a sensor. So in a room, there is a classroom. You are just deputing a robot to clean the room. Okay. Is it going to be without sensor? Is it going to be observable or non-observable? It will be non-observable because it is not having a sensor to understand where is the dais, where is the benches. So many objects would be there in the classroom. Okay. To identify all those, to predict all those objects, accordingly to move to the empty spaces and to clean, the robot will not be having a sensor. So without a sensor, what will happen? It will move as in, every place, and once it's got hit by wall or by the desk, it will come to know that there is an object. Then it will take a diversion. That is known as non-observable. Okay. Beforehand, you will not be knowing. Once it's come across, as he said also, no, traffic. Beforehand, you may not be know how much traffic may be available without a Google map. Okay, you may not be knowing that there is a congestion. Once you came across, you may take diversions, you may take other steps, to find a solution for that. That is non-observable. And then partially observable. Any example for partially observable? See, we said that fully observable. One example is chess. Similarly, with the game, can you say partially observable? Some games with partially observable. Any game with the partially observable? You cannot say fully what your opposition and you are playing.
Chess,
Chess only fully observable. Full board is visible to you. You can literally see what you are doing, what is opposition person is doing. What is partially observable? Focus. The cards.
But chess also
Chess, you do not know what is he is going to play. Okay. But you definitely knows what he is having in front of him. See, even now, recently, there was a game played. I think some Sinkfield Cup or some tournament where there is this small guy. Okay, until this guy has come across before 1 year, the history was held by Pragnananda, our Indian player. That history was youngest GM. Okay. Until this fellow was coming up, this history was with the Pragnananda only. Recently, it was broken by him. Okay. He was also an Indian origin player. Anybody knows his name? I'm not getting his name immediately. He is some 16 years old or something. Okay, and he has broken Pragnananda record, being an youngest GM, and recently he has played his tournament with all top players. Okay, what he has done, everybody's laughing when he was playing. Everybody was laughing at him. The reason was he just. The thing is, neither of them are moving on the boards. Okay, whether see always what will happen is if both of them are playing, you once you made a move, you start. Suppose 6 hours they are playing means 6 hours they cannot sit. So they'll just play their moves and they'll just go out for, especially when they are playing classical. The other person to make a move, it may take 20 minutes or 15 minutes or 5 minutes. They'll, in order not to sit, they'll just make a move. They go for a walk or something. Okay. So what will happen is, so at least one of them will be sitting on the board for making a move. In that particular case, what will happen, in what has happened, why everybody is laughed is, none of them are sitting on the board, none of them are making a move. Okay, it's because this fellow, what he has done is, he has to make a move, but he has just went and was standing beside the opposite person to see the moves from the perspective of opposite person. He has to play white coin means he's not thinking from sitting on his table. He just went and behind this person who's playing a black, he just was standing there and seeing what are the options from the perspective of the opposite fellow. So now you tell me, is it observable or fully observable or not? Not only from his perspective, he is seeing the board. He is visualizing the board by standing on the literally opposite person's side. See, people will think from opposite person also, they'll just play, but he literally does that. Physically, he has done that. Okay, when he did that term as a kid, everyone started laughing. So that was the thing. So it is fully observable, right? What is available with respect to your point, others' point. Whereas the same thing is possible in poker game. Can you able to see the other card? The person is holding which card?
No, madam. We cannot.
So yeah, now can you able to see the difference between the chess and poker game, which is observable, fully observable, which is partially observable?
Madam,
It is poker. Yeah.
cricket game, we know that it's going to be a 20 over, what will be the overs and per over, what is the number of balls, and we know only number of players, all we know.
Okay, let us take a cricket. It is a fully observable or partially observable?
Partially observable.
Partially. Why it is partially observable?
Partly observable.
Huh? Anybody is hiding anything? See, it is not that. See, it is not that how you are playing the game. It is not with respect to how you are playing the game. What is going to be the result? It is not possible for any type of games.
Okay.
Okay, if I'm playing any game, nobody in the opposition, nobody can think like how I am going to play or what is there in my mind. That is for every problem. How we are saying this is fully observable or partially observable is based on the state space, the problem space. Okay, tell me now, what is the space? What is the problem space? For chess, what is the problem space? Based on the problem space, okay, we are going to define them as fully observable or partially observable or non-observable. Okay, what is the problem space for chess? What is the problem space for cricket? What is the problem space for poker game? What is the problem space for cleaning the room by Roomba? What is the problem space? In AI term, it is also called a state space. Can anybody define what is state space? Define state space.
All the possible states are definable, then that is
Yeah, perfect. All possible states. Okay, all possible states in order to find a solution is known as a state space. Okay, so suppose I'm going to find, to solve the problem of the parking problem in SRM University. What is the state space? Can anybody say what is the state space for this problem? See, literally I can say it is the entire scene. Entire scene is the state space. So now you tell me what is the state space for this particular problem.
a space which is empty, which doesn't have a building, doesn't allot as a playground.
No. I've already said what is the problem. I already given where I am going to solve my problem. Now you tell me what is the state space for this problem. What is my state space? Okay, what is that space in SRM? Is that some area left over for parking or what? See, the state space is the entire SRM university. That is a state space. Am I right? Are you able to follow? Oh, so now you tell me for cricket, what is the state space? What is the problem space? The entire ground, right?
Yes,
including the entire stadium. And for chess, what is the state space?
The board.
The board, you and the opposite person, everything includes the state space. For poker game, what is the state space? Visibility of all the cards, you and opposite person, and the entire, table, everything around you. Everything related to that is state space. Okay, I want to go for eating a biryani. I want to go to some Talapakati, which is there in OMR or somewhere from SRM University. What is my state space? What is my state space? I want to travel.
Traffic.
The entire Chennai is my state space. I can go. See, that entire Chennai covers everything. Okay, I can go via this route or that route or a different route by any vehicle, by any traffic, whatever it is. That is up to you in terms of solving the problem. But the state space is entire possible state where I can perform all my actions. That is known as the state space. Is it clear now? State space. Is that Tamil Nadu is covered in this problem? Tamil Nadu is my state space in my traveling from SRM to OMR.
Oh, madam, we have clearly defined it is limited to SRM
we
to
know.
OMR.
Exactly. We know that as starting state, initial state, we know that goal state. Okay. Similarly, in finding a parking problem, I clearly state that what is the problem, where it will be initiated, where it is going to occur. Okay. So you cannot say that V8 is also the state space for that kind of problem, because my problem is surrounding there, but surrounding anywhere it would be of SRM. So that entire SRM would be the state space. Similarly, for this, I have clearly defined where is my initial state, where is my goal state, and it is going to revolve around only that space. It's going to be only in Chennai. Okay. So now, tell me the chess is fully observable or partially observable? If the entire state space visible to me. See, I want to travel from Chennai to OMR. Okay. Is it fully observable or not?
Fully observable.
Is it fully observable? Provided if we are in Chennai, we already might have visited OMR. We know that where OMR would be available. Okay, I want to go to Andaman Nicobar, one island in Andaman Nicobar. For the first time, I'm going to visit. Is it fully observable or partially observable? First time when we are traveling to new city or new place, we may not be knowing everything, right? We may be seeking the travel guide or somebody. We do not know where that island itself. There are several islands. We may not be knowing which island located where and how to go from the ship to ship or whatever is from the flight we have to take, or only through ship we have to travel. We may not be know all this, right? Everything is not visible to us directly. We cannot able to predict. So this is what. So poker is partially, and this chess is fully observable. Everybody's clear in that.
Okay, ma'am.
Yeah, unknown state space. Unknown state space means you cannot see anything. As I said, no, traveling to some Andaman Nicobar Islands, you do not know what is available, how to go, Nothing is first time you are traveling. Nothing you are unaware of. That is why the so many tourist guides or they are planning, no, like a GT holidays kind of people. We have to approach. Then problem characteristics. Any problem, no, can be characterized into these kind of steps. Is the problem decomposable? Can solution be ignored or undone? Is the universally predictable problem? Do you want a break or when do you want a break?